Yeah,
I'm just going to do it in the browser.
Yeah. So they fixed it somehow. Yeah.
All right.
Yeah. And then just go to present.
Present.
I think there's like a presentation mode or something. That'll work. I mean, it's big enough. All right. So you can hear us. Thank you. This is the TLS working group session 1 of 2. Joe and I are the chairs. You can find some information in the charter there. So here's our plan for today. First, the note well. Since it's Monday, you might not have seen this. This is the brief summary. Basically, you agree to disclose IPR if you've got it and topics that are relevant that are going to come up today. You're going to follow the process. Any contributions that you say, including at the microphone and email on the Jabber everywhere, are covered. The other thing is that this session is going to be recorded. So what you say at the mic is going to be remembered. And for further details, you can ask us for the specific links, but this is basically it. Oh, the blue sheets. Yeah, thanks. Thanks for helping us do the process thing. The blue sheets are going around. Please sign them. We're going to need some minute takers. Do I have any volunteers? All right. Thanks, Joe. Basically, kind of get the topic. You don't have to do word for word. That's just not doable. Jabberscribe. Anybody in the window? At least. Okay. Thanks. Matt, great. Reminders, please state your name at the microphone for the scribes in the minutes, and let's keep professional at the mic. What's next? So this is the agenda. So we had a little fun with the agenda time. Yeah, go quicker. So you'll note there's a big draft thing after Wednesday because we haven't actually finalized how much time all the slots are going to get. But basically Monday, we also added exporters authenticators to the beginning there. Hopefully Nick's here because it's a working group draft and he did have some updates. So we're going to do the administrivia, document status in a second, and then we're going to run through these 3 drafts, the exported authenticators, Martin's idea about record size limit extension, and then SNI encryption. Is that you? Okay, well.
Is this working now?
Does it still work?
Yeah.
Okay. Great. And then Wednesday we're going to have we're going to talk about the main drafts, the TLS 1.3, the DTLS draft, and then we're going to go into another topic about data center use of static Diffie-Hellman and essentially some rebuttals. And Tim's going to give us a little quick talk about a project that they're working on. And if we want to batch that part of the agenda, let's do that on Wednesday. Because I think there'll be plenty of time in there to discuss about that stuff. So is there any other agenda bash for today? Yeah. Okay, so document status. Okay. We got the ECC Cypher suites for TLS 1.2 and earlier is in the RFC editors queue. We got the ECDH PSK with AES stuff is through the ISG awaiting Ecker's clear on the discuss. We believe that the last version actually addresses it, but he needs to tick the button for us. And he will look now. And the 5289 to proposed standard, I think, is done. Since the last meeting, we adopted 3 drafts, the DTLS 1.3 draft, the exported authenticators, which Nick is going to talk about in a second, and the TLS certificate compression draft. There's no update on the certificate compression draft, but we believe there will be next time. And TLS is completing its second working group last call, and Ecker's going to talk about those on Wednesday. And it's going to complete, I think, tomorrow. So if you have anything else to say, great. Please don't open up any new things that aren't really super important. The Dane draft, Dane record and DNSSEC authentication chain extensions we'll talk about on Wednesday. And it's through working group last call, so we're going to try to address the working group last call comments on that so that we can move it out into the wider world for the DNS crazies to argue about later. Then we got 3 drafts in progress, the IANA registries update, example handshakes, which I think literally just got updated on Monday. Thanks, Martin. And applying grease to TLS extensibility, I think just expired, but we can get we can kick that back up. At the last meeting, we talked about delegated credentials. We didn't say no, never. We just said it needed some more work. So Subito, we can figure out, I can stick you together with the people that have the other questions, and we'll see if we can get that one rolling. And Peter Gutman's TLS 1.2 update for long-term support is kind of patiently waiting. And that's it for the document status. Any questions? Excellent. First up is Nick. There he is, great. He's in the back, he's gonna fix it.
Okay, all right, great. So hello everybody, I'm Nick Sullivan. I work at Cloudflare. Exported authenticators. Let's go to the next slide.
Is that us? This one better?
Okay, it's good to go. Yeah, the buzzing has gone down. Let's go to the next slide. So exported authenticators, this is a way, given a TLS connection, to take an additional certificate and bind it to the connection and provide proof that that certificate's private key is in control, is under the control of one of the parties of the TLS connection. And this can be either the client or the server. And this visual diagram kind of demonstrates the typical and expected use case for this, which is that you've already established a TLS connection between a client and a server, and one of the parties uses this exported authenticators API, providing it a certificate and a key, creates a exported authenticator, which is essentially a certificate proof, sends it to the other side, which then can validate that this is actually, yes, a certificate and a key. This does not change anything on the wire in TLS. This is an out-of-band exported value that can be sent through the tunnel at the application layer. Next slide, please. So this was initially presented, I believe, at IETF 97. It was adopted as a working group at IETF 98. In the meantime, we've made a few changes, but this was sort of inspired by building a working implementation. We have a fork of Golang's crypto library that Watson Ladd worked on, as well as upcoming Nginx boring SSL implementation, which is underway. This is deployed. We have a test site. We've tested this in conjunction with the secondary certificate authentication in HTTP2, which was one of the inspirations for this draft. There have been several updates since last IETF in response to things that we found during implementation, as well as comments from the mailing list. One of which is that the signature and the HMAC are both asymmetric, so you can't take an exported authenticator from the client and pretend it's from the server, so and vice versa. The certificate verify, in the meantime, had been updated in TLS 1.3. We updated our draft to match kind of exactly with what TLS 1.3 is doing. We also limited the types of signatures that you could support in this to TLS 1.3. Although exported authenticators works in TLS 1.2 and 3, the crypto itself is only TLS 1.3, as well as we cleaned up the text in response to several questions when people were confused about the meaning. This is now also on GitHub, so any additional issues would go there. And that's about it. So that's all I have.
How many folks have read this document? Please raise your hand. About 10.
So, yeah, Martin Thompson. The question that I have is, do we know of any open issues other than, I think, the one that's open, which is we don't actually have a formal analysis that this is safe to use, at least on the server side, I think was the whole.
Right, we don't have any, there are no other open issues. This was shared with several cryptographers who gave it a once-over and didn't provide a formal analysis, but said their intuition was that it was generally secure.
And so the plan remains to wait for more formal analysis before we publish something like this, or where are we at?
That's the question here.
Yeah. Because otherwise, I think this is in pretty good shape.
Yeah. So my problem is, right, like I can only incentivize the researchers so much, and then somebody has to like take it and do it, right? So maybe working group last calling it will incentivize them to take a look at it. I don't know. Ecker?
Well, we could ship it as well.
Yeah.
Yeah. Wow. Goofy. Yeah. So probably be worth making one more pass at this. I'll sync up with you afterwards to see if we can try to kick to do a little bit of work. I got to call people in mind. I mean, I think we shouldn't wait too long. I think, you know, like if we don't have a formal analysis by, you know, Singapore at latest, we should just go to working about call. But it'd be worth spending a little bit of time trying to get it.
All right, cool. So I guess that's the plan is we'll wait, and if we don't hear anything by Singapore, we'll pull the trigger. Great. And I guess if you want to do implementations.
Yeah. Yeah. Let me know. We can do some interrupt testing.
All right. Thanks. Next. No, it's Martin's up next. I love pictures.
That's good. So I'm going to be quick. We've had a bunch of discussion about max fragment length, which was defined way back when with RFC 6066. That's a great mouthful. Next slide. So there's a lot of complaining about max fragment length. It doesn't actually address the use cases that we have today. Only the client can choose how big fragments are. There's only, I think you can choose 256 up to 4K, I think are the sizes for the things. And you can't extend that. So no one can say that they support 16K frames, or records rather, which is kind of unfortunate because that's a really good size for records when you want to transfer a lot of information across. Which is the reason that for the next point, which is that if as a browser I wanted to offer this, and I kind of wouldn't mind offering this sort of thing, I can't really do that with also taking a hit on the size of the records that I'm willing to accept. They go down to 4K. And there's no way of saying as a client that you're willing to limit the size of the fragments that you send to a server without also limiting the size that the server sends to you in all cases. So as soon as the server supports this extension, you end up stuck with small records. And that's not ideal. The other thing is it's completely symmetric. So once you negotiate max fragment length, both sides are expected to respect the same value. So long list of problems. The draft goes into this in a lot of detail. Let's do something better. Next. This is my last slide. Simple. You put a number in your in an extension, and that's the limit that you have for records, and the other side can do the same, and everyone's happy. It's not really a negotiation. You just advertise your limits, and the other side advertises their limits, and everyone's happy. It only governs the encrypted records. As I understand it, people send really large certificate messages occasionally, and they'll be perfectly welcome to do that in a single record. And once it's in the clear, there's not a lot of value in adding extra record headers to everything, so I didn't change that. I haven't yet pushed the button on 01. There was a bunch of discussion on the 00 draft, some minor tweaks to the language regarding various musts and shoulds and whatnot. Doesn't really change the details of the proposal. So I'm proposing we do something like this. Okay.
So this is an individual draft, right?
This is currently individual. Yes.
Yeah. So I support taking in the working group, which I guess is where you were going with this.
That's where I'm at.
I was just going to send you a PR, but then you said something that surprised me. So now I think we need to discuss it.
Okay, sure.
So what would happen if there was some version of TLS which encrypted the certificates?
then they have to respect the limit.
Okay, so
Yeah.
I guess the reason I'm pushing on this point is that basically the
primary limitation here is if you're running an AEAD and you want to allocate a certain amount of space to hold the entire ciphertext and then transform it into a plain text, you have to have the whole thing if you want to do this right.
sure.
And as a receiver, and if you don't want to allocate too much memory for this sort of thing, then
Sure.
that's not
I guess
you can still stream in a certificate over multiple records.
Of course, yes. I guess what I'm getting at is that, like, it seems like having an exception for plain text records is not helpful, given that we're moving to encrypted certificates.
The ones that I'm concerned about most is the client hello and the server hello,
Well, so I mean
which might fit within these limits, but
so specifically the client hello, of course, the client has no indication of what the server will accept.
Right.
But the server hello, the client does know what the server will accept. The client will accept. And so, I mean, I guess, I mean, maybe it doesn't matter, but we can discuss it later. But I mean, the reason I got up about this was because was like that there's a mismatch. I mean, you're right to say that like people do have big certificates, but given that like that's the biggest thing, and now we're encrypting it, like having the exception doesn't actually help us very much.
maybe I misspoke. The point was the AEAD is really the key, and that was the set of complaints we got. Yeah, there's only minor tweaks on the thing. I think we should do this. It's pretty simple.
So can we ask how many people have actually read this draft? So about 10 as well.
Some.
There's been pretty, I mean, this was discussed on the list, I would not super extensively in context of the TLS 1.3 discussions,
15 messages or
but
something.
pretty good.
250.
So let's do a hum for working group adoption. So Kathleen, do you want to get to audio position? Yeah. The lovers, I think everyone's going to love this. So I'm going to ask two questions, one for working group adoption and one for not. So please hum now if you think we should adopt this as a working group item. Please hum now if you do not think we should adopt this as a working group item. Obvious that we're going to adopt it. So we'll take it to the list, obviously, and in 2 weeks or whatever, we'll get back with a definitive answer, but looking pretty positive.
I told you I'd take less
Yeah, I know
time.
you were going to take the time. That's great. And now we have a good hour and 15 minutes to talk about encrypted SNI. So Christian, you're up. You only have like 6 slides, so it's not that many, but still. This topic has consumed vast quantities of time because it's an important topic. So.
Thank you, Sean. I suppose that's what I get for sending my slides in advance. I get to present on Monday.
Yeah. I appreciate it.
Thank you. Well, there have been many debates about SNI encryption or not. I can see here people who want it to happen, and then it did not happen for a variety of reasons. So after listening to all those debates, I decided, hey, maybe I should throw my hat in the ring and do something there. Can I get the next slide? So what has changed? What's the reason? There have been a series of reasons beforehand to not try to have the complexity of SNI encryption in TLS. And the main reason is that, hey, the other side of the boat is leaking too. Why should we plug our leaks? It turns out that the other side of the boat are plugging their leaks. We have first a deployment of HTTPS. A big proportion of the communication are encrypted, so that's good. Leaks are fewer and fewer. We have the next leak is the classic thing, which is the symmetric of the SNI is a DNS request. A typical transaction, someone will resolve a name and then use that as the SNI for the next TLS connection. And so it makes little sense to go to great lengths to encrypt the SNI if the DNS request is in clear text. Now what does change is that we start having deployment of DNS or TLS. It's standardized and there are deployments. So we we are to the point where we can find encrypted DNS transaction, and then the SNI is the only leak. So you want at that point to fix that. And that's it. The pressure increases to actually get a solution. And then that means that right now SNI is becoming the preferred tool. I mean, if you want to do censorship, as in do not go to swissbankaccount.com, you have two ways to do that. You have one way, which is to block it in the DNS, but that's easily circumvented. And you have the other way, which is to do packet inspection, find the SNI in crypttext, and block it. So, hey, how can we get out of that? So, next slide. The high-level summary is, I don't know. I'm just a scribe here. Okay. Everything that is in the SNI encryption draft is text that was on the mailing list, which I basically organized, and I worked with Eric on that, and to make sure that I was not saying something completely crazy, and to organize. So basically, the first thing I got from the mailing list was the list of known attacks against the SNI encryption. The biggest, I mean, I'm not going to recapitulate all the attacks on the mic. I mean, they are listed in the draft. And if you read the draft and you find attacks that I did not correct, well, I'll be happy to scrap them down. The big one are typically the kind of replay attacks. I mean, there's a class of attacks in which you hide the SNI, but then someone replays your connection. Or use a side channel on the other side and say, okay, replay the encryption connection, use the side channel, find out what you did. And if we don't fix that somehow, then again, it's not worth it. So I went through that, and basically, if we go to that, there are still a couple of solutions that are plausible. And I listed these plausible solutions in the draft. So, next slide, please. The first solution, which is not a TLS level solution, but which is actually deployed to some degree today, is basic HTTP fronting solution. Okay, you have a website called, say, fronting.example.com that accepts to mask the HTTP connection to hidden.example.com. And in the simplest implementation, you just do a TLS connection to this fronting site, and then over the TLS connection, you do an HTTP request to the hidden site. And people actually do that today. And there is some deployment. The big advantage of that solution is that, well, you can do it. I mean, if you are, the only thing it takes is some level of cooperation so that the fronting site can serve the content of the hidden site. But you can do it. And that's what it's done. The big issue is a trust issue. Is that, well, first you have a generic trust issue in all these fronting solutions. Is that if you go via an intermediary, the intermediary will know who goes there. So if you are concerned about surveillance, for example, the intermediary the fronting site becomes a target for surveillance. But that's common to every solution, so we are not going to debate that. In that particular HTTP solution, what happens is that the fronting site actually serves the content of the hidden site. And that's a really big trust issue. Because that means that if the fronting site is somehow subverted, not only do you find out who's accessing, but you can also serve them content of your choice. And that's kind of risky. There's another issue, which is the discovery issue, which is common, again, to every of those solutions, which is, okay, how do I find out that in order to go to hidden.example.com, I have to actually go to fronting.example.com? And the classic solution today is word of mouth. It's that you learn that from your buddies. But it's not, doesn't necessarily scale, so it's an issue. So we had discussions, I mean, several of us had discussion about what would be the plausible solution there. And the plausible solution there to make that HTTP solution better is to have some kind of a proof. I mean, basically having a certificate that says that, hey, hi, the hidden site assures you that you can use fronting on my behalf, it'll be fine. And of course, you have to make sure that you do that in the right way. You have to make sure that the certificate is done correctly, that it cannot be spoofed, because clearly there is an obvious attack in which the bad guys will say, hey, in order to access your bank account, go to my own site. It'll be fine. And, well, it will not be, okay? So you need to be very clear that when you sign that certificate, you have a way to audit the certificate, a way to make sure you really want to have something like certificate transparency. You may want to use multiple certificates from several authorities. You may want to use a TLSA record of some kind as an addition, and that's an issue. Okay, you want to have a good expiration date because I mean, these things have a tendency to become obsolete over time, and again, you want to make sure that it's there, and you clearly don't see how you're going to manage a revocation list or something like that. So basically, it's short expiration date. You want to make sure that people don't do random stuff like that, saying, hey, in order to access example.com, go to Dan's website. And Dan has a small server, and suddenly you receive millions of connections and it gets lost. So that means that probably in the certificate, the proof shall be bilateral. It says, not only does Hidden say that yeah, it's okay to go to fronting, but the other guy says that too. So that you get it right. And we mentioned the revocation attack. I mean, what happens if your fronting site suddenly turncoats because they have been convinced that they should help somebody else? So that proposal is for the HTTP solution, but it can actually be used for any of those solutions because the problem it's solving is a generic problem. And so if in the certificate you specify the type of access that you want, are you doing HTTP? Are you doing an HTTPS connect, which is a tunnel inside HTTP? Are you doing one of the TLS 1.3 solutions we'll be looking at later? You could put that in the certificate as well. And that could be like the one-point shopping for saying how we can organize this SNI encryption, HTTP fronting stuff. Now, the issue with the HTTP solution is that if you want to not completely trust the content, you have to fall back to HTTP Connect, basically using the HTTP site as a proxy. And that means double encryption. That means some very weird data paths in your data center. It's not necessarily something we want to do at a large scale. The other solution that we have, I mean, I've looked at two solutions that are mentioned in the TLS working group. One is the so-called quasi-tunnel solution. So it's an extension, it's a way to use TLS 1.3 that was first described in the Tokyo meeting, I believe, and which basically assumes that you are going to send two client hellos. So the first client hello is going to the fronting side, and the second client hello is going as zero RTT data to the fronting side too, but it's really meant for the hidden side. So you do this 1-2 punch, and then the client hello is delivered to the hidden side, and the server hello comes back from the hidden side. That works in a TLS 1.3 because in TLS 1.3 the certificate itself are encrypted. So the actual server hello frame doesn't say from where it comes from. And it has, the big advantage there is that you achieve two very good characteristics. First, it's end-to-end. It is basically your encryption key is renegotiated with the hidden side, not with the fronting side. So you remove all that vulnerability in which the fronting side could deliver the wrong content. And also it has only one encryption. I mean, after the first phase, you have just one encryption. So it's a pretty good solution for that. It does not require a standard extension per se. I mean, the bits on the wires don't change if you squint right. It does require changes in the implementation. It requires that your implementation, your fronting side, knows that it's going to receive zero RTT data and that it will have to look at those zero RTT data and do something with it. But hey, it's doable. So that's one of the solutions. The other solution is the so-called combined ticket solution. So the combined ticket solution is basically a way to use session resumption tickets. Suppose that when you ask for a session resumption ticket, the receiver, the server, if you want, sends you a ticket that has an extension in that says which SNI you shall use for the next connection. So you get your ticket, which is just a regular ticket, and then you have this indication that, oh, for the next connection, don't use hidden.example.com, use fronting.example.com, or whatever it is. And that means that when you're doing that resumption, the client hello arrives at the fronting server with this resumption token, which is effectively, it doesn't say anything, it's just a regular token, and the fronting can examine this token and somehow, maybe because he has a database, maybe because they have been using some kind of shared key between the fronting and the hidden to encrypt the token, or at least encrypt the first bytes in the token, or something like that. It finds out which hidden server it is for, and then forwards the client hello to the hidden server. And then you do a normal resumption. So that's really elegant. It works really well. And it requires some cooperation between fronting and hidden, let's say. But I mean, all of them do. It also requires some ticket extension. Basically, you have to have a way to say, in my ticket, oh, that's my SNI. And that has to be in the clear, of course. And the big limitation is that it only works for session resume. It doesn't work for the first session. So for the first session, you'll have to use something else. Like use the HTTP fronting solution, maybe with an HTTP connect inside, or use the quasi-tunnel solution to get your first connection there and establish it. And all that is, of course, described in the draft. Next slide, please. So an example of the combined ticket, I was looking at how to do that. If you look at the syntax of the ticket in TLS 1.3, there is actually an extension field. So in order to make that work, we could absolutely use a regular ticket from the client point of view. Okay, we could use a regular ticket and just define an extension that carries the SNI. In fact, you could use the SNI extension itself and just put it there. It would work. You need to understand, you need to change the client behavior so to the client understand that extension and resumes with the hidden server, but that's, well, yes. And you need to also find a way to negotiate that ticket between the client, between the hidden and the fronting servers. it will be tempting to try to align that implementation with the definition of delegation token for the HTTP solution. Because again, the delegation token explains why this is a good idea. The obvious attack with that is that if I am a malicious site, I can send you a resumption token and it becomes a DOS against some server that I've put there. So maybe I need to put more than just a name. I need to put an authorization or something. But it's if we place the delegation token as another extension there, it'll be probably fine. So at that stage, I'm not saying that, hey, we should do A or B. I'm just trying to say, hey, should we walk in that direction? Is that something the IETF should do? Is that something the working group should do? And I think that between the delegation token, between the combined ticket, having them standardized properly, having a common architecture, I think, yes, that's something we should do. And I think that if we do it, we might have a very good solution. But now I'm probably
So I guess we're kind of throwing it up to the floor, and I'm sure the mic line will get very long. But I want to thank you for putting together the summary, because those are all the three things that I remember the way that we talked about it. Was a very concise way. And we'll take a cue. We'll do some cue moderation. So we got the microphone at the front, so fire away.
Kazuho Gufasui. I'm interested in implementing any reasonable form of encrypted SNI, and I think that all the methods being discussed in the draft seem fine. On the other hand, I'm a bit sad that the fact that the number of round trips required for establishing a connection increases in some cases due to use of encrypted SNI. And for the matter, I think that we should consider transferring more data over TNS, such as the certificate and a semi-static DH key, and revive the TR3.3 semi-static DH key form, so that we could do a zero RTD handshake of TLS using the information transmitted over the DNS. So that if we do that, we can improve both performance and privacy.
Brett Jordan. I have a question, or more or less a concern, about SNI encryption. This may or may not be popular amongst the group, but I attended a talk at RSA by Google on their Beyond Corp strategy, basically controlling their network without firewalls, and their extensive use of middle box technology to protect their own network. It seems like a really cool idea. Google's done it. It seems like a really great way for the enterprise going forward. My concern with encrypted SNI, that means that these enterprise organizations like Google are going to then have to decrypt everything that traverses in order to identify what's going across in the payload. So there would be no way to selectively decrypt only certain types of traffic. So banking traffic or whatever is now going to be decrypted on these middle boxes. And I wonder if we have extensively thought about the risk that is associated with that, because enterprises like Google and others are going to run middle boxes and decrypt this traffic. But if there's no way for them to selectively identify that this is certain types of traffic that they may not want to decrypt, then all of that is going to be in plain text in some chunk of memory on some box that could be exploited.
So, Kristen, do you want to respond? Because my thinking is that we're not the protocol police, and we can't enforce people to implement everywhere, and these are optional standards. So I see your point, but it might not get the point.
Well, I must say that there are examples of Google deploying exactly that for some of their customers. The HTTP fronting solution. So, I mean, they must have thought of that.
Yeah, beyond Corp.
Yeah.
Actually,
So Kathleen Moriarty, AD. I do want to make sure that this conversation has had enough on the ops area working group, although list or OPSEC, because although we might not be the protocol police, this does have a large impact, and we've already seen the fallout of not having the conversation initially, right? So one of my questions I was going to get up at the end and ask, it's good that you have the attacks enumerated, but do you have the uses of this enumerated, just so we know what we are shutting down? And that was a good example of capabilities that will be impacted, right? And trade-offs. We have to look at the trade-offs.
Yes.
Philham Baker, Komodo. I like this, the way you've broken down the problem, in that I particularly like the tunneling piece. There is another way that you can view it, however, and that is to view TLS as being two separate protocols. One, a key agreement protocol that results in a ticket, and the second, a session protocol that involves using that ticket to talk to a host. And in traditional TLS, those two are with the same host. In future TLSs, in things like dprive, etc., maybe they're different. The other point that I'd make is that when you were talking about maybe introducing a new type of certificate, I think that terminology was unhelpful in the context of TLS, in that what you're having is nothing that's going to look like a PKIC certificate. And in particular, I really can't see why you would want to put this information into certificate transparency, because I think that this is something where you would want the opposite of transparency for, because you're trying to conceal. And so I think that what you have there is more akin to when you connect up to the actual server, you want some sort of acknowledgement in that handshake with the server that you've gone through this other rigmarole with the fronting server. And that's the way that I would bind it together, rather than with introducing a new static certificate.
Okay, Phil, you're making 2 points. I'll try to answer those 2 points in sequence.
Only two?
Well, the first point you have is about this separating the key agreement and the actual connection. And I think that, in fact, the combined token solution is very close to the design you mentioned there.
Yeah.
And by all means, I mean, if you want to contribute, just okay. The other one is about this delegation token.
Yeah.
And I must apologize. I am kind of an amateur there, and I used the wrong words. I should not have been certificate, because we are going to read that into being PKI, which is not what I meant. It's effectively a signed blob. That's what it is. And, well, you had a corollary there about the use of CT. The use of CT is not on that blob. The use of CT is on the identity certificate used to prove that you can sign that blob.
Yeah.
So that's basically, you have that blob that you sign with an identity, okay? And I have to verify that it is signed by some responsible guy, so I'm not going to trust anything. And because there is a high risk of attacks there by spoofing, I want that signature to be really, really verified. And that's why you want to check that the certificate that is mentioned to prove that you can sign is actually the right certificate.
Right. I would prefer to use a different form of authentication that doesn't involve signatures. But we can talk about this offline.
And by all means, I mean, look, I mean, as I said, I'm just, none of that is my creation, okay?
Yeah.
I'm just trying to collect the IDs and put them down.
Right. Okay. Let's take it on.
Daniel Kahn-Gilmore from the ACLU. Christian, thanks for doing this work, for documenting it, and for bringing it here. I hope that we can, as a working group, adopt it. I think this is important work. I'm not particularly convinced by arguments that that this is going to cause the end of the internet as we know it. So I'm happy to see it going forward. One caveat that I wanted to note with the solutions that are basically fronting solutions. You had mentioned the risk that the fronting site can basically attack the confidentiality and integrity of the messages coming from the hidden site. There's also actually a risk that goes in both directions, in that if there's any legal liability about the hidden site, if the fronting site is passing the traffic in the clear, the hidden site can actually cause the fronting site to have additional legal liability. So those are arguments for doing the work here to get to the point where a fronting site can just offer connections without being able to know the details of it. So yeah, I'm happy to contribute work on this, and I hope that we'll adopt it.
Ben Schwartz, Google. So again, to repeat DKG, thank you very much for doing this write-up and thinking carefully about these issues. I really appreciate it. I definitely support this draft. On the topic of Beyond Corp and corporate network architectures, I'm confident that there's no impact here because anybody who controls a domain name that they don't want to be subject to this, that they don't want to participate in encrypted SNI, simply would not authorize or promote the use of encrypted SNI there and wouldn't support it on those servers. So I think that's not an issue. And I do want to suggest that there might be one missing or one additional requirement that might be helpful. And that is that I think a really good solution here is one that is a positive performance or classical security improvement to the system, and or a positive operational improvement to the system. I think I'm really much less interested in solutions that are cryptographically correct, but that don't provide an obvious benefit to the server operator, especially the fronting site. Otherwise, I think we risk creating something that really gets very low usage, as opposed to, for example, the current fronting systems, which are very widely used not because they offer some sort of SNI hiding capability, but because they offer operational advantages to CDN operators.
Rich Sauls, Akamai, nice segue. Yeah, I think this is good stuff. I'd like to see only one mechanism. I have a preference for the re-encrypted client hello, because then we could chain them and do Tor purely in TLS. But yeah, I would help work on this for real this time.
Which is a change, I'll note. Yes?
Hi, Subodh Iyengar. I just had 3 comments to make. So I think one comment I had was that this kind of feels like it's merging two different things together, like protecting the IP privacy with the fronting server solution. It's like putting the IP privacy and also encrypting SNI that's hiding the SNI information. So I'd like a solution which kind of like separates those two in some way. Like clearly, we would not be using a fronting solution if we were going with fronting server solution if we were going with SNI. Another comment is that I'm concerned about the ability to supply fronting server hostname with the combined ticket. This is similar to some concerns that we've had with the origin server frame in HTTP working group. So I would take a look at that and see what the arguments against that were. And like the third one is that I'm surprised you initially mentioned some application-based solutions and like in the HTTP layer, and then you don't mention it in the potential working group app solutions. That is, for example, one potential solution could be using Alt SVC with exported authenticators so that you can do it completely in the application. And so you could say that, hey, the first time, yes, you don't get privacy, but then the second time you point to like whatever fronting server that you want, and then you can authenticate that you own the fronting server with exported authenticators inside the connection, similar to how people coalesce domains right now. So yeah.
Yeah, I'm pretty sure that the exported authentication may be a way to simplify some of the design. And,
yeah,
and just send an email and explain it.
Sounds good.
Okay.
So, Eric Rescorla, as sort of co-scribe, I think this is something we should be working on. I also am concerned that we have too many mechanisms, and we probably should spend some time trying to bash them into one I wanted to sharpen, I think, the point Brett was making, because I think people may be not quite understanding it, and maybe he can correct me if I'm misunderstanding it. That there are some inspection endpoints which, and we're going to mention this on Wednesday too, I think, which examine the SNI, and sometimes the server certificate in order to determine whether to man in the middle or connection. And so the idea is you have a man in the middle box in your network, and it looks at the SNI and then maybe the cert. And if it is a banking certificate, then it doesn't inspect. And if it's a if it's a, I don't know, Facebook certificate, it does. And so the concern here, right, is that anybody who is willing, if you're in the non-inspect bucket, and you agree, and it becomes known or suspected that you are fronting for anybody else, then you have to end up in the inspect bucket. And at the limit, everybody ends up in the inspect bucket. I think I've understood that correctly. So I'm not saying I think that's an incredibly important consideration. My understanding is the not inspect bucket is typically like banks and people like that who probably aren't going to front anyway. But maybe the policies are different, configured differently than I expect, in which case this might be an issue. The point I think that Subodh made is that there are a bunch of natural extensions to this sort of domain fronting that are where basically you have a bunch of co-tenanted servers that are all basically up, but all that share the same credentials effectively, and all you're trying to do is hide SNI between like foo.github.com and bar.github.com, and those are things which we have a bunch of HTTP mechanisms to enhance, and so we can probably make them better. The things that are the things we don't have solutions for that probably require solutions at TLS layer are the ones where you wish the fronting server not to have access, as you were saying, to the plain text. So I think that's the cut we need to be making, is between solutions which are just about streamlining ordinary domain fronting and ones which are about hiding the plain text from the fronting server. So I think, I guess the last thing I was going to say is, yes, it would be really great if we could figure out some way to streamline the discovery of who the fronting servers were. But I think that, yes, as Ben's making this face, that's also a separate idea we should be trying to fix. But I think we'd probably would be maybe to deal with one and then the other. And it's worth noting that probably if you did think you had an out-of-band mechanism for distributing like a public key for the fronting server, that would make Martin's sort of Martin's fake tunnel mechanism look more attractive than the cookie mechanism. Though we probably could find some way to make the ticket thing work too. Actually, I guess that would probably work too, because you could simply wrap the identity in the ticket. Yeah, essentially the same. Yeah, so it's probably the same.
Philhan Baker, it's the mention of the Kurt Tor piece suddenly made me think that, one of the killer applications for this could turn out to be providing easier ways to evade geolocation blocking. So you'll be able to get your Game of Thrones fix.
Yeah, I mean, the draft has been very careful to not mention motivation too much. But I get Kathleen's point that we should mention the operation issues, and in particular the point that Eric was outlining, that, hey, there are reasons for a website to not use fronting. And the reason is when you suspect that your treatment under your exposed identity will be better than the treatment if you hid your identity.
So Kathleen Moriarty, I fully understood all of the examples and the implications, and that you wouldn't have to encrypt SNI. There was just lots of discussion at the IESG retreat that when things like this come up, that the ops area is notified and has a chance to speak up.
Yep.
Right? So I'm honoring that and making sure we have that discussion first, and it's documented, they have a heads up instead of being shocked later. It's just easier.
Yeah.
So thank you.
Hi, Nick Sullivan, Cloudflare. I'd just like to echo Ecker's points about separating the idea of a fronting server that does not have access to the plaintext and one that does. And when thinking about focusing this work on the example in which your fronting server does not have access to the plaintext, there may be sort of a cleaner way to think of this. I don't know what it is, but it seems like a lot of these ideas are very focused on SNI encryption and not maybe on a more generalized problem of content tunneling, with TLS inside TLS, things like that.
No, it's okay.
Brian Ford, EPFL. Just want to echo, well, both first express my support for this in general. This is something very important to work on, but also echo a couple other comments. One, looking at it as a potentially more general thing. I think Rich said, brought up the point we should think of, kind of does this nest, can you, negotiate a tunnel within a tunnel efficiently, does it work, if and when we need it for 2 steps and not just one. Yeah. We should at least think about that carefully. I think, kind of backing up, in a general sense, the discovery problem is very close to a routing problem at a higher level, overlay network kind of thing, discovering these relationships. Now, I'm not proposing to jump into any kind of routing, problem activity, and of course the discovery problem should be kept separate.
We could use secure BGP to discover the.
Yeah, okay. Well, I'm not proposing any solutions here, but anyway, just in terms of thinking about it, there's some very interesting connections, and to be. To think about, but anyway, great work. Thanks.
Okay.
Okay, I'd like to get an idea of how many people have read the draft. Okay, a lot. Very good, very good. And I think right now what I'd like to do is get an idea from the room of who thinks this area is something the working group should be looking at and working in. So I would take and that's kind of not picking a particular solution. Yeah. But just this kind of area, and we'd have to do, kind of continue Christian's work here and figure out the right way to frame the work. And that would probably also at some point involve interfacing with the ops area. Martin.
Yeah, so Martin Thompson. I'm not sure that we actually need to take a hum whether everyone wants a pony or not. The question is that, the trade-offs that we have to take for the solution, then it gets interesting. So what information are you looking to get from this room? Has anyone actually said that they don't want a pony?
Yes. Well, actually, that's not true. There was at least some of the people I talked to quietly that said they didn't want this. Okay. Because the encrypted SNI makes it hard for them to do stuff. They should, but they're not.
Yeah.
So we'll just do a hum to confirm that. Right. So if you think the TLS working group should take on this work, please hum. If you do not think that this is a topic the working group should take on, please hum. Okay.
So if anyone that hummed no wants to get to the microphone to state their piece, feel free to do so. We'll give you an extra strong flame suit.
I did not hum no, but just a quick follow-up question and possibly a scoping question. To what extent should this, or should we maybe consider separately traffic analysis vulnerabilities? You alluded to some of these issues. Some of the attacks, like especially the replay attack, that makes it really easy, to break the hiding in some cases, but also there are a lot of ways to look at TLS traffic. TLS is a very leaky protocol in other ways for traffic analysis purposes, and kind of the rest of that problem might be a big enough ball of wax that we should deal with it separately. But I just wanted to bring that up, as an important, closely related problem.
Is that a question for me or for the shares?
It's a question for whoever wants to answer it.
So my feeling is that we're not going to do TLS-7 now, that we probably just scope it and say what properties it actually supports and leave it at that. If we make it bigger, we'll never get done. That's my concern.
Yavner, and if for a moment I can wear the vendor hat of the vendor that I no longer work for, then firewalls started with filtering based on SNI because it wasn't clear, but then he figured that sometimes the client sent the wrong SNI because there was just one certificate at the other end, so it didn't matter. So they started filtering by the names in the certificate that was returned from the server. Now, at some point, we figured out that we're not going to get that certificate in TLS 1.3 because it's encrypted. So I said, okay, we'll fall back to doing things with SNI. And now, we're taking SNI away from us again. So that makes filtering harder, and that means that you have to do TLS proxying where you didn't need to do that before. So that's just the firewall view of things.
Daniel Franca, Akamai. I would like a pony, but I do not think we should be adopting this draft yet. I think we should have a more clearly defined recipe before we have about 200 cooks on the task, and that this would be better addressed by a much smaller design group coming to us with a better defined proposal before adoption.
So I guess my argument is that I think that this draft actually just lays out the options. It didn't actually pick one. So even if we were to adopt it, we haven't asked that question, but if we were to adopt it as is, it's not saying pick this one. So you could argue that this is the design document that you could work on, and at the end say, here are the 5 options we considered. We picked number 3. So there's ways we could do that if needed.
Yeah, I mean, I agree with Daniel. It's too early to pick any given solution. I think that what I was hoping to get out of this conversation was that we want to work on this, and then I think we're somewhere at the moment between a coalition of the willing and a design team, and I guess I would hope that by Singapore, people be ready. We might enough of us may get together and say we think we should do X. That either we're that we're ready to have a discussion about which things we should do, or at least we're ready to convene a design team to try to pick one. Yes. To flesh out the options. But I think I agree we're not ready to pick a solution. And I mean, I think in terms of document mechanics, if people think it's important to have a document, then certainly we can adopt part of this document as a problem statement or whatever. But I don't think that's important. I just think it's important to agree we're going to do the work and we make agenda time for it.
Yeah. So I mean, to be clear for the minutes, Joe, like we have agreed that we wanted to work on this, and then however that ends up happening is how it happens. And I actually don't think, Kathleen, that we need a charter extension for this. We don't need to recharter for this because it's okay. So great. That is it for today, folks. You get an hour back. Thank you very much.
And we'll see you on Wednesday.
So do you want to have that chat now about what you found out? All right, cool.